Dear student, this is Venkatesh Prabhu, our bioprocess principles teacher. As far as the fourth unit in the bioprocess principle is concerned, there are four main topics are there. The first topic it is batch reactor. And microbial growth curve. Growth curve. A logistic equation in batch growth or logistic equation in a batch growth curve. And the next topic it is continuous reactor. And the last one is fed batch reactor. So these are all the five major topics we should be concentrate on this in this unit 4, and all this comes under the category of reactor operations. So the reactor can be operated in a batch mode or fed batch mode or continuous mode. So as far as batch reactor is concerned, we need to derive the equations for a batch reactor that I have already finished in the class itself. Microbial growth curve also I taught in the classes. So this performance equation I have derived in the class. When you plot a graph with respect to biomass and time, the nature of graph, it resembles like a sigmoidal shape. Sigmoidal shape means it looks like a S-shaped curve. So it will be like this. So in general, when the growth is taking place in an exponential phase, it should not be in an X-shaped curve, it is going to be an exponential curve that looks like this. So the y-axis is going to be x, x-axis is going to be time. This x, that is biomass, can also be represented in terms of number of cells or the product in terms of biomass Sp. So the same thing, in the sigmoidal shape curve also we can represent P or N or X with respect to time. So the x-axis or abscissa, it is the changes with respect to time, and the y-axis it could be a biomass or number of cells or the same biomass which can be mentioned in terms of P. What I am coming to say is, if it is an exponential growth curve, the biomass it is going to be changes with respect to time and it goes to infinity. But in the case, this is not an actual case, it is going to be occur. So the actual growth curve it is going to be in the form of sigmoidal shape curve. So at one point of time, when t is equal to t, the x tends to x infinity. This is called as load carrying capacity or logistic term, which could be a toxin which is going to be produced as a byproduct which can suppress the growth of the biomass. So the term exponential phase, again it leads to the stationary phase, so we will get a sigmoidal shape. So this is the x infinity term. So for this, the differential equation, how we can mention it is dx by dt is equal to k. K is the rate constant, k into x into x infinity minus x. So x is going to be the changes in x, infinity is the final value, that is going to be again divided by x infinity. Let us take this differential equation as equation 1. So we can write this equation as dx by dt is equal to kx of 1 minus x by x infinity. You take this as equation number 2. Then this 1 by x infinity can also be written it as q for our simplification. Take this as equation 3. Substitute equation 3 in equation 2. Then equation 2 can be written it as dx by dt is equal to kx of 1 minus qx. Take this as equation 4. Okay. Now we need to integrate this equation. When it before integration it should be separate. So how we can separate is that is rearranging this equation dx by x into 1 minus qx is equal to k into dt. Take this as equation 5 and integrate this equation with the limit of x naught to x and this term as times 0 to t. So when you are integrating this term x into 1 minus qx, it is not easy to integrate easy directly. So follow partial fraction method to simplify the integration. So equation, the term integration term of this alone can be written it as 1 by x into 1 minus qx can be written it as a by x plus b by 1 minus qx. Okay. Now rearrange this equation as 1 is equal to a into 1 minus qx plus b into x. Now apply the condition to find the value of a and b. When you assign x is equal to 0, then this qx term will become 0, bx term will become 0, then a is equal to 1. To find b, when again assign x is equal to 1 by q, then this qx term will become 1, 1 minus 1 becomes 0, then a term will become 0, then b into 1 by q is equal to 1. With this b is equal to q, you will get. Substitute the value of a and b in the equation 5, then we can write this as 1 by x dx with the limit of x naught to x plus integral of q by 1 minus qx into dx is equal to integral k into dt, the limit 0 to t. Now when you integrate this x naught to x into 1 by x dx, this is going to be ln x by x naught. When you integrate this whole term, this can be written as minus of, because minus term is there, minus of ln of 1 minus qx divided by 1 minus qx naught. Put bracket here is also, this is equal to, when you integrate this, it is going to be kt. Take this as equation number 6. Now what you need to do is ln of a minus ln of b can be written it as like this, ln a minus ln b is equal to ln of a by b. Like this we can write this equation as ln of x by x naught divided by 1 minus qx divided by 1 minus qx naught. We can write like this is equal to kt. Taking exponential on both sides, then this equation becomes e power ln of the whole term is equal to e power kt. Whole term means x by x naught divided by 1 minus qx divided by 1 minus qx naught. So this and this will get cancelled. We will get x by x naught into 1 minus qx naught divided by 1 minus qx is equal to e power kt. Take this as equation number 7. Now we want x alone. So x is equal to, rearrange that to equation 7 as x is equal to x naught e power kt into 1 minus qx into the, here there is one more term is left over, that also you can include here, 1 minus qx naught. I write once again, x into 1 minus qx naught is equal to x naught e power kt into 1 minus qx. Simplify this term, x naught e power kt minus x naught e power kt qx. Here left hand side we can write it as x minus x into q into x naught. Let us have this number as 8. Again rearrange this equation, bring all the x term to one side, then x minus x into qx naught plus x naught e power kt qx is equal to x naught e power kt. Take the common x term, x into 1 minus qx naught plus x naught e power kt into q is equal to x naught e power kt. We want x only, x is equal to x naught e power kt divided by 1 minus qx naught plus x naught e power kt into q. Resubstitute q is equal to 1 by x infinity. Then x is equal to x naught e power kt divided by 1 minus x naught by x infinity plus x naught by x infinity e power kt. Rearrange this. X is equal to x naught e power kt divided by 1 minus of x naught by x infinity, taking common term 1, that is minus into 1 minus x minus of minus into minus e power kt. So x is equal to x naught e power kt whole divided by 1. This is the equation for logistic curve. Logistic curve means load carrying capacity in the growth curve. This load carrying capacity is the toxins which is present in the growth that will suppress the growth of the microbes. So if this whole term is not going to be present, or when you consider this whole term is equal to 0, then x is equal to x naught e power kt, that is an exponential equation. This is the exponential equation. So this is going to be a fraction which is going to be present in the growth that leads to the changes in the growth curve, that is the sigmoidal shape of the curve. That's all for the logistic curve. So x is equal to x naught e power kt divided by 1 minus x naught by x infinity of 1 minus e power kt. This is the final equation for the logistic curve. Thank you.